This is Nathan, and this is my Village Simulator. So I made this about a year ago during my Christmas break, and I just thought I'd take the time to kind of show what it does and explain the code behind it. So right off the bat, you can see there's some pretty interesting terrain. It was made using the Unity terrain tools, and the map itself is pretty simple. So we have a mine over here in the corner for the miner, a mountain up here for the blacksmith and the smelter, and some trees down here for the collector. And we have this capsule here, which is actually the player itself. The player has the camera for the Unity scene embedded inside of itself, so the camera will follow the player where it goes and also rotate with it. Okay, so now going into the simulation, we're just gonna kind of follow around the capsules to their jobs. So starting with the miner, which is appropriately colored silver, like the iron that it mines. The miner's going to go into the cave, disappear for a bit, and then periodically it'll throw some iron ore out of the cave. And once the iron ore accumulates, the smelter will come down from the mountain, collect it, and bring it back up for smelting. While that happens, we're going to move over to the berry collector. And the berry collector is a pretty simple creature. It goes from tree to tree, collects berries, puts them in its bowl, and returns to its glass container for drop-off. You can see there's a bit of wonkiness going on with the container and the grapes, and that's because the colliders for Unity don't really fit shapes that aren't circles or squares. So I also know that grapes don't grow off of trees, but grapes were the most fun thing to design in Blender, so that's what I went with. It's been a bit of time, so I think the smelter will be coming down from the mountain relatively soon. And yes, you can see the miner running down with its container to collect. So it's going to curve around and go towards the mine. And yeah, it'll grab those objects, throw it into the container, and then return right back up the mountain. And the way that I designed the pathfinding for the miner is it'll essentially lock onto a monument like this tree here, pathfind towards that, and then lock onto the next monument, which would be the terrace up there, pathfind towards that, and then return to the last monument, which is its smelting furnace. And so that way there's a relatively simple way for it to pathfind. I'll go into the pathfinding for the other characters in a bit, but yeah. Once the smelter returns the container to its original position, it'll start picking out little pieces of iron ore for it to throw into the furnace over here. And so it was difficult for me to animate the smelter picking up objects of iron. I wanted it for the items to be on top of its head and to kind of be like it was hoisting them over its head, but I found the most simple and pain-free way for it to look like it's carrying the iron ore was just for me to make the iron ore objects become child objects of the smelter. And I'll explain in a second how this kind of links to the larger phenomenon for this project, which was really applying object-oriented programming principles to Unity's class system, which made programming for it relatively straightforward and pretty fun. So kind of moving on to the coding section. So once the smelter finishes smelting, what is supposed to happen is the blacksmith would then pick up those smelted objects and turn them into hammers and such. And my end goal for this project was for the blacksmith to then sell, and for this to be kind of more of an economy simulator, but that's kind of more of a future aspiration. So anyways, moving on to the coding, I'm going to start with the movement script for the player character, which is the most simple to explain. But essentially, we have this capsule here, which is the player, and as I mentioned earlier, the player has the camera for Unity for this scene embedded inside of it so that it follows it around. And in terms of the movement of the character, which then carries over the movement to the camera, we have a very simple script. So it's only 4 lines. I used a different method before involving rigid bodies, but I found that this method was more effective, so that's what I'm sticking with. Essentially, we have this line here which takes the forward input of the keyboard, so up and down arrow keys, and stores that temporarily for every iteration of void update in this forward variable, and the same is done for the left and right keys. And so essentially the way that Unity runs is it uses C# scripts, and these C# scripts are kind of started as soon as the program is started, and as the name suggests, void start is called first, and then every frame void update is called. And all of these are within the movement class, which is the script class. So, within void update, every second, or every frame, the current input information of the keyboard is stored in the forward and side-to-side variables, and this transform variable or object is accessed. And so to give a bit of context to this transform object, if you look to the left here, you can see the Unity interface, and the way Unity allows developers to manipulate objects and characters and enemies is through accessing attributes of the object class, so the object. And so one such attribute is the transform attribute, which stores information about the geographical location of the Unity, or of the object within the game. So Unity uses the Cartesian plane, XYZ coordinates. So the transform of an object stores information about that object's XYZ coordinates, its rotation along those axes, as well as the scaling along those axes. And so by accessing this transform object in the script, I'm able to get information about the object's current location, as well as do operations on, or use the methods of that object's class on it to transform it, to translate it in a certain direction or rotate it. So in the script, I translate the object in the direction forward or backwards, depending on the arrow keys, that it's currently facing, and rotate it left and right depending on the arrow keys. Moving on to the blacksmith, as I mentioned earlier, as the blacksmith goes up the mountain, the blacksmith will lock onto sort of checkpoints or milestones or monuments. And so the first monument would be this tree here. And for each of these monuments, it will first calculate the distance between the transform of the blacksmith and the transform of that monument, or that pre-stored coordinate, using the getDistance function, which is kind of a helper function. It takes 2 vector3 data types as parameters, which are essentially just data types that store, or vectors that's, or I guess matrices that store XYZ information for an object, and calculate the distance between those, calculate the distance between the object itself and, or the 2 objects, using basically the quadratic formula, or for 3D scenarios, vectors, the length of the vector. And so essentially it gets the distance, and it also calculates a new vector, which is the direction between the object that it's trying to go towards and its current location. So it calculates that vector that it would need to travel in that direction towards the object. And every time update is called, it will start a coroutine which will transform it in the direction of that object. So essentially it locks on, finds the distance, and then shrinks that distance by moving towards it. Now, the miner does a very similar thing when it moves towards its mine, but once it gets to the mine, things are a little different. So the miner will then activate a coroutine once it reaches its destination that essentially creates a new object. So it will take the ore object that is in the game and create a child of that object, which has the exact same attributes, like, you know, the exact same appearance and the exact same location, actually. And then it will create an object, put it into a array of game objects, which will come in handy later, and then it will add a force to it, so like it'll throw it. And you can kind of see that happen, or you might have seen that happen at the beginning of the simulation, where the ore was just thrown out of the cave. And so, moving on to the blacksmith, or sorry, moving on to the berry collector. Actually, you know, let's move on to the smelter. Moving on to the smelter, we can see here that the smelter, also similarly to the blacksmith, moves up to its mountain and then comes back down. And when it collects it, it will actually take all of the ore objects that have been created thus far, and it will clear the... It will first move those objects in the array that I mentioned earlier of game objects, array of iron ore, and then add it to its own array of objects in its container. And then from there it will clear the array of game objects that the smelter has. Or sorry, that the miner has. And in that way we can have not only a physical removal of the iron ore, but also a non-physical removal in terms of the data, in terms of keeping track of possession. So yeah, moving on to the berry picker. Actually, one more thing I do want to go over is the miner is actually able to trigger methods of the iron ore through accessing it through referencing it in the top of the script here, through the Unity interface. So essentially you can create a reference in the script and then kind of give or tell Unity which object you're referencing inside the Unity interface inspector. But essentially it gets a reference to the iron ore object, and then it's able to trigger the method within the iron object that involves duplicating itself. So yeah, moving on to the berry collector. The berry collector moves from tree to tree, as I mentioned earlier. Similar process to the ironsmith locking onto milestones. But the added complexity here with the berry collector is instead of just going to a preset location, the berry collector will actually choose a tree. So I'm just going to restart the program a little. As you can see here in the script, the berry tree's script, or the berry collector's script, starts with this void update here, and what happens is it will check to see if this target variable is empty or if it is storing something. And the target variable is the transform of a given object, but not a preset object, just a object. Hence why it starts out null. And so essentially the point of this target variable is for it to store its current target, which tree it's currently trying to go to. And so at the beginning of the simulation, it's not going to go to any tree, or it doesn't know which tree it wants to go to. And so if it doesn't know which tree to go to, it will trigger this for loop, which will help it to select a random tree and also get the distance of that tree and find and set the target variable to that tree. And once the target has been set, it will, and once the direction has been set, it will constantly get the distance between the transform of the berry collector and the transform of that tree and then move towards the tree through transform, translate, and a movement coroutine. And so once that happens, it goes towards the tree, collects the berries, and once it gets to the actual tree, a new clause is triggered here, and a new path is triggered, and essentially once the distance between the tree and the collector is below 1, or the collector and the basket is below 10, it will trigger a function or a method in either the berry object that involves either duplicating itself and dropping itself into the bowl of the collector here, or just moving itself and dropping itself into this container here. And you can see here the method spawnBerry takes a parameter, which is the transform of the collector itself, and that's because we want to drop the berries inside of the collector's basket. So the location it drops is the transform location of the collector. You can also see it's encountering some issues here because it's not able to get within 10 of the basket, like I mentioned earlier, which is causing issues, but it's also trying to get towards it, so it's kind of shaking. But yeah, back to the script. For the despawnBerry function, which involves moving the berries into the basket here, the argument is the transform of the barrel itself. So that way the berries drop into the barrel. And so yeah, that kind of concludes the software and the just kind of like a quick walkthrough of the simulation. Hopefully that was interesting, and hopefully I was able to explain some of the rationale behind this program. Thank you for watching.